Alright, let's get everyone up to speed. On October 28, 2014, the Orb 3 mission exploded seconds after liftoff. 6 months later, to the day, Progress M-27M also exploded at third stage shutdown. This jeopardized the International Space Station, because 2 of the 4 available cargo resupply vehicles had suffered anomalies in close proximity. After the failure of the Progress mission, extra cargo was added to the next resupply mission, which would launch 2 months to the day after Progress M-27M. This time they were flying a SpaceX Falcon 9 with the original Dragon, on a mission called CRS-7. Now of course, down 2 missions so close together, SpaceX really needed to make this one count. But of course, you can probably guess by the fact that I'm talking about it that this mission is not going to make it to space. It is 10:21 a.m. Eastern Daylight Time in the summer of 2015. Of the 3 missions I've talked about in this series, this is the only one that I personally watched live. And the reason is landing legs. Now today, this might not seem strange except for the fact that they're white instead of black. But back in 2015, there was a lot of people, wiser than myself, that still thought trying to land an orbital class booster was a total waste of time. The very first SpaceX Falcon 9 to ever fly with landing legs was just over a year before this, in April of 2014. And as of CRS-7, SpaceX still had never had a successful landing. The first would come at the end of 2015. Now, of course, with hindsight, we know that the Falcon 9 pulled it off and is incredibly reusable. But I'm under no illusions that I was predicting the future by being excited about these missions. I just thought what they were trying was cool, and they also weren't afraid to show a few explosions. But of course, you know that this is not going to be the mission that lands. In fact, this isn't even going to make it to the drone ship to crash.
1, 0. Liftoff.
Up until now, the Falcon 9 had been very reliable. This was its first in-flight failure, and as of 2023, it is its only in-flight failure. NASA's independent review team provides a timeline of what we all observed during that live stream. Around T+2 minutes and 19 seconds, we see the first sign of gas exiting the second stage. At the time, the first stage was still burning and was performing exactly as expected. A second later, we see some combustion in that cloud. After only 2.5 seconds, the Dragon spacecraft breaks off of the Falcon rocket, and after 7 seconds, we see a much larger combustion event inside of the gas cloud. Then, around the 8-second mark, they shut down the engines on the first stage, and the entire vehicle breaks up. As far as you can see on the live stream, this whole event only lasted about 8 seconds, but personally, it felt like it lasted a lot longer when I watched it live. From here, things played out a lot like the Orb 3 investigation, except this one took an extra 3 years to complete. SpaceX established their own accident investigation team, and then in August of 2015, NASA set up their independent review team. Well, they didn't actually set it up, instead they decided that the Launch Services Program would act as an independent review team. I don't really have any insight on how this is different from the Orb 3 investigation or why it's different, but it is this team's report that I'm going to be referencing for the video. The whole purpose of an independent team is to investigate concurrently, but also validate the efforts of SpaceX in a non-cynical way. Dot your I's, cross your T's, that sort of thing. From the Independent Review Team report. Around the time of the failure, telemetry was not showing any obvious degradation or worrying trends. In the words of the IRT, the vehicle went from flying fine to conflagration in less than a second, or within the blink of an eye. Now, this 800 to 900 millisecond event obviously is not the complete breakup, which lasted 8 seconds. This is what triggered that breakup. SpaceX and the IRT both eliminated any causes in the first stage or the spacecraft, narrowing it down to the second stage. This is also where they made the determination that the actual cause of the failure was the rupture of the stage 2 liquid oxygen tank. The primary scenario that would have caused this rupture is that a helium-filled composite overwrap pressure vessel, COPV, broke loose, floated up, and then hit the top of the LOX tank dome. Now, what is a helium COPV? Well, for a variety of reasons, rocket fuel tanks are pressurized, and you want to pressurize them with a gas that will not cause an explosion. For a long time, helium has been the gold standard because it's lightweight and inert. Helium is stored in a high-pressure tank. These are thin metal tanks which are then wrapped with carbon fiber in order to reinforce them, hence the name Composite Overwrap Pressure Vessel, or COPV. Now, this conclusion was not immediately obvious. They actually investigated multiple alternative scenarios. They identified two main scenarios which could have caused a similar failure. The first was that a leak could have occurred on the LOX transfer tube, which runs from the LOX tank through the RP-1 tank to the engine. This scenario assumed that the RP-1, which is warmer than liquid oxygen, would leak into the transfer tube, causing the liquid oxygen to boil and spew, or geyser as they call it. But thermal analysis showed that there wasn't enough thermal energy between these two propellants to cause that much boil-off. Scenario 2 is essentially the opposite, where liquid oxygen leaked out and mixed with the RP-1. This would transfer more thermal energy, and it wasn't clear if this would be enough to cause the failure. To test this, they actually constructed a chamber at the Marshall Space Flight Center in Alabama, and after about 2 weeks of testing, the IRT determined that there was greater thermal energy transfer, but it still wasn't sufficient within this 800 to 900 millisecond time span, which is why the IRT ultimately agreed with SpaceX that the COPV separating from its mounts was the proximate cause. They also determined that it's credible that the initiating cause was the failure of an axial strut supporting the COPV, and specifically that it was a stainless steel eyebolt, also known as a rod end, which broke under ascent loads. Now, there's two main forces we want to look at to understand the situation. The first is buoyancy and the second is weight. Because the rocket is accelerating at over 2 Gs, its weight is going to be about double what it is when it's sitting on the ground. But its buoyancy will also be double what it is on the ground. So there's double the net force. Now, while SpaceX and the IRT agreed on this chain of events, the IRT did have a couple issues with how SpaceX described the failure. In SpaceX's version of the report, they said that a material defect was the most probable cause. But the IRT didn't agree with this view because there were several other probable causes. There could have been manufacturing damage. The strut could have been misinstalled. There could have been some other kind of collateral damage, or some other part of the actual strut which broke, causing the same chain of events. And finally, the IRT pointed out that this was more of a design error. SpaceX had selected an industrial-grade component as opposed to an aerospace-grade component. And they put this slightly lower-graded component in the critical load path, which, if it failed, would obviously lead to a failure of the mission. The IRT said that the implementation was done without adequate screening or testing of the industrial-grade part. SpaceX ignored the manufacturer's recommendation to use a 4-to-1 safety factor when using the component, and obviously, this design error is directly related to the failure of the Falcon 9 during the CRS-7 mission. They also took issue with other components, specifically wire ropes, which were also being used without regard to manufacturer recommendations, but which they determined weren't a direct cause for this specific failure. They recommended that there was additional attention put towards evaluating commercially sourced parts. So in summary, the IRT determined that, subject to SpaceX implementing some of these corrective actions, the anomaly was resolved. So what is the moral of the story? What did we learn? What is the through line between these three failures which caused them to happen back to back to back? The answer is absolutely nothing. This is 3 completely different launch vehicles from 2 different countries, 3 different organizations. There's no common hardware, no common causes. Each had a unique cause. The first was a defective engine, the second was a defective payload adapter, and the third was basically poor quality structural parts. The only thing that binds these 3 failures together is that they happen to fall within 12 months of each other, which is unique, but also a coincidence. After looking at all 3 cases, you might be tempted to say that the answer is testing. All 3 reports cite lack of testing as a contributing factor, but but that's not saying a lot. Lack of testing is a contributing factor to basically every failure in all of spaceflight history. I mean, there's basically nothing that can go wrong on a rocket that you couldn't have technically predicted if you sat down long enough and did enough planning. But the truth is, if you tried to engineer a rocket that way, you are going to be stuck in analysis paralysis forever. When these reports say that additional testing should be included in the future, it's not condemning the engineers that built it, it is just letting them know this is why it failed, so keep an eye out for it in the future. Learning from your mistakes is an essential part of spaceflight. Space is hard, and sometimes the only way to learn what's going to make your rocket fail is to launch it and find out. But even with the changes from these 3 failures, this would not be the last failed mission to the ISS. 18 months later, they would lose another progress due to a different issue with the 3rd stage. 3 years later, Boeing's Starliner, which is a completely different vehicle, would fail on its first test flight. And that's just uncrewed missions to the ISS. Obviously, there have been other failed missions in the meantime. So if you're going to take anything from the series, it's what I said at the very beginning of the Orb 3 video. This was just a harsh reminder that space is not routine. You can test and plan, but no matter what, there's always something else that can go wrong. Thank you so much for watching. This video series has been obviously inspired by the style of Jon Bois. I also have to thank BobbyBroccoli, who did a tutorial on how you can create animations in Google Earth that I might be using in the future for some things, but I'm probably going to get back to my normal style after this because these take a while. I hope you all enjoyed this series, and I will see you in the next video.